We're going to look at acceleration. In particular, we're going to look at calculations that involve constant acceleration. At GCSE level, the only acceleration you have to worry about is constant acceleration, certainly in terms of calculations. Acceleration is the rate of change of velocity. When we use the term rate in physics, what we're meaning is how much it changes with time. When we look at velocity time graphs, we can find the acceleration from the gradient, how much the velocity changes with time. If you're a little rusty with your velocity time graphs or you're unfamiliar with them, then I've got a video on that topic. I'll leave a link in the description below. Also, you can subscribe and you can then easily find all my other videos. I'm going to use the term velocity in this video. Velocity is the vector version of speed. It's basically speed that can be plus or minus. Again, I've got a video all about vectors and I'll leave a link to that video in the description below as well. Acceleration is just change in velocity with time, and we can find it from the equation, change in velocity divided by time. We often use the Greek letter delta to describe change, so delta V would be my change in velocity. You will see the Greek letter delta in lots of physics equations. When you see it, just think change. You could also write V minus U for the change in velocity, where V is the final velocity and U is the initial velocity. Here's an example. What's the acceleration of a lorry that goes from 0 to 14 meters per second in 42 seconds? Our change in velocity is 14 meters per second divided by 42 seconds, which gives us 0.33 meters per second squared. Notice the unit for acceleration there. It is meters per second squared. Deceleration you may have heard of. It's just a negative acceleration. Let's take a look at an example. A bicycle slows down from 8 meters per second to 3 meters per second in 2 seconds. What is its acceleration? So the acceleration is our change in velocity over time taken. And our change in velocity we can find from our final speed minus our initial speed. Our final speed is 3 meters per second and our initial speed is 8 meters per second. So our change in velocity is 3 minus 8. We divide that by 2, the time taken. So 3 minus 8, which is minus 5, divided by 2 gives us minus 2.5 meters per second squared. That minus sign is important. It tells us the acceleration is negative and that it's slowing down. Now, if the question did ask for deceleration, we wouldn't need to worry about the minus sign because we're already implying that it's slowing down by using the word deceleration. So the deceleration would be 2.5 meters per second squared. But the acceleration is minus 2.5 meters per second squared. There's another slightly tougher equation that you need to be familiar with at GCSE. That's v squared minus u squared equals 2as. Remember, the acceleration is always going to be constant. This is where v is the final velocity, u is the initial velocity, and a is the acceleration. We use the letter s for distance or displacement. An aeroplane accelerates at 2.5 meters per second squared. Its takeoff speed is 75 meters per second. So how long does a runway need to be for the aircraft to take off? The first thing I like to do when there's something complicated is write down a list of all the numbers, the variables involved. That helps me pick the right equation and get the right numbers in the right place. So in this equation, v, the final velocity, has got to be 75 meters per second. The initial velocity, u, is 0 meters per second. The acceleration is 2.5 meters per second squared. And I don't know what the distance is, so I'm just going to write a question mark for s. If I now look at the list of equations that I'm given on an equation sheet in an exam, I can find an equation with those variables in. And I find v squared minus u squared equals 2as. So let's substitute the numbers in. Actually, before I solve this, can I just ask you to take a look at my website where you'll find lots of resources, questions, answers to go with this video and every other video I do. And if you could take a moment to like and subscribe, I'd really appreciate that too. It helps me continue to produce these free resources. I also love to read your comments. Now back to our solution. The equation we're going to use is v squared minus u squared equals 2as. Our final velocity, well, that's 75 meters per second, so we put in 75 squared. Our initial velocity is 0. So 0 squared is still 0, so 75 squared minus 0 equals 2, which is 2, times a, the acceleration, which is 2.5, so 2 times 2.5, and we leave s as s. It is the unknown in the equation. We now simplify this equation to make it easier and more recognisable as just a simple algebra expression. 75 squared is 5625 minus 0, well, that just is 5625. 2 times 2.5 is 5. We want to get the s on its own, so we need to get rid of that 5. So we get 5625 divided by 5. So the 5 is times on one side of the equation, so it becomes divide on the other side of the equation. And if you bung that in your calculator or get your pencil and pencil sharpener out, you get 1,125 meters equals s. You can see why a lot of runways have to be quite long, can't you? Now, when you watch this, watch this one. Watch it, watch it, watch it. Go on, go on, go on, please. Go on, watch it, watch it. Watch that one.